Hi folks, welcome back to my ANSI SQL class. Today we're going to talk briefly on joining data. And I'm going to talk a little bit in advance about the joining topic. If this was a theoretical class, a database theory class, we would spend an enormous time on joining data because that is really the heart of the relational database aspect. But we're creating this ANSI SQL class for developers. So I'm going to go through and explain how joins work and what a join is, but we're not going to go through a lot of the theory. I will explain to you so you understand what you need to use when. But when it comes to the bigger picture, again, I could spend probably 2 weeks on this topic alone. So keep in mind that joining data is really one of the most important aspects of maintaining a database. It's why the relational database is so popular. And what it does is it allows me to normalize my data, to also make sure that my data is very accurate. Can you imagine that every time a customer placed an order, you have to go back through and fill out all that customer information over again for every order item that you put in? You really want to put the customer information in once and then fill in an order. And that's what the relational database aspect gives us. If we look at our baseball data that we've been playing with this quarter so far, you'll remember that we have the player data and we have batting data. Could you imagine every single time you have to update that batting data that you had to fill in all that player data over and over again? What we really want to do is fill that player data in and then have a lookup table for the batting information. So every time we add a new piece of information to batting, all we have to do is put the player ID in, and we can use that player ID if we need to go back in to that player table and get back the player's name, if you will, or their height or their weight, etc. So let's go ahead and start taking a look at what we've got with different types of joins. So again, as I mentioned before, one of the most important reasons that we join tables is to reduce redundancy. Redundancy means that aspect of having to type data in that you don't need to over and over again. For example, if your customer orders 10 items, you don't want to have to type in that customer's name and information 10 different times. That would be redundant information. You would be storing that both in the orders table and maybe even in a customer table. At the same time, you can use this to increase accuracy. An example of creating of the accuracy aspect of it would be what I do with my websites or my desktop applications, because I depend upon the city and the state to be accurate. So when a user comes to my website or they come to or they're using my desktop applications that I write, I allow them to type in the zip code, but what I will do is use a zip code table to automatically go out and grab the city and state and plug it in. And the reason I do that is because you can imagine how many different ways the city of Coeur d'Alene, Idaho could be typed in. It could be typed out longwise without an apostrophe, just CDA, and I want to make sure that when I go back and I sort by city and state that all the Coeur d'Alenes are going to sort together. And by me having that lookup, I'm increasing my accuracy. I'm making sure that they're not going to fat finger that city or state. And another example is the ability to view multiple entities as a single entity. So once we get these joins together, I have the ability now to join, for example, players with batting. And when I run my select statement, it's going to look like one table coming back. So rather than have these two different entities together, when I join them, I'm going to get one entity returned, that join data. And it's going to look to your program receiving it. In fact, it's not going to know it came from a join. It's not going to know that it came from a view. It has no idea. It just knows that it received data. So it says, as we discussed later, the power of the relational database is to logically design your tables to make data at least as least redundant as possible. Again, that means that you want to make it so that your data entry people or your customers or whoever has to type the least amount of information in to get exactly what you're looking for. So again, this is giving the example on the slide I just gave about my zip code table, or the example of a client address information. Every time you want to order a product, you don't want to make the client have to complete their client information. Imagine going to Amazon and every time you add an item to the shopping cart, having to go back in and put all of your information each time in. You don't want to do that. You want that order to be related back to who you are. And that's what this is all about. So we're going to find out that there are several different types of relationships that we're going to deal with. And we're going to look at the meaning behind them. Really, what is the purpose behind that data? What do we want back? So there's an example called a one-to-one relationship and another one called a one-to-many relationship. And the fact of the matter is how we code these is exactly the same. What really matters is what we as users we as programmers expect to get back. So an example of this would be that zip code lookup that I gave you. That's a one-to-one relationship. If my client types in 99207, I expect as the programmer to get one city and one state that's going to be returned back. Spokane, Washington. If I get multiple cities or multiple states returned back, there's something seriously wrong. So me as the programmer, when I write that, I'm going to grab the very first city and state that comes back. I'm not going to expect multiple pieces of information to come back. So it's how I code that. On a one-to-many relationship, that's a little bit different. A one-to-many relationship says that you could have one record or zero records returned back or many records returned back. For example, let's take our baseball database. Let's imagine a brand new player coming in and be entered in. They've never played a game yet, but I'm putting them in my database for the very first time because I know they are going to be playing games down the road and I need to have a player ID so I can start storing their data. Well, the moment that I put that player in, they have no batting information. So, but potentially though, they could have as many years as they've played. So that is a one-to-many relationship. I know that when I put a player ID in and I say go back up and look at in batting, I can either get 0 years back or I can get a record back for every different year that they've played. So my expectations as a programmer is I have to look for 0 or more records coming back. Whereas with the zip code table, I know there should be a one-to-one match. But again, this is theoretical. How we write our joins is going to be exactly the same thing. It's what we expect to get back as the programmer. So let's talk about these relationships together. So what I've got is a little bit more complex join here. In this class, we're typically going to just be joining 2 tables. But in this particular case, I'm joining 4 different tables together. Customers, orders, order details, and products. Now, let's just take a look at what our expectations are or what kind of joins we would expect to get back from this. So if I've got a customer, that customer, just as I mentioned with that baseball player a minute ago, could be a brand new customer and they will have either 0 or more orders out there, right? They may have no orders because they're brand new, or they could have been dealing with me for years and I might have thousands of orders for that customer. So that would be a one-to-many relationship. I would expect to get back from orders either 0 or an infinite number, which means then later in my program I have to loop through those. I'm going to have to grab one at a time out until I run out of records. So it's how I program it. Now let's take a look at orders to order details. So you've got this order, and the order has different lines in it. And this is like your shopping cart. So the orders would be the basic shopping cart. What would you expect to see when you open your shopping cart? Order details. And again, the same thing holds true. You can say, I'm going to order a product, but until you actually physically order it, then it's not going to be a detail. So for example, if you're looking on Amazon and you're going to order a hard drive, right? So you're putting that order together, it doesn't become an order detail until you actually put that hard drive in your shopping cart. But you could have 0 items in that, or you can have an infinite number in there. So that order, I guarantee Amazon's not going to stop you from ordering as many items as you want as long as you've got the credit to cover it. Now, let's take a look at that orders detail, because in that orders detail, you're going to order a product. And that product now has a product part number or a product ID. Now I know that when I go back to my inventory, which is this products on the right hand side over here, if I go back to my products, I better find one product that matches that product ID. If I put in part number XYZ, I better find only one item that matches XYZ. Otherwise, if I ship that to my customer, I might ship them the wrong item and they would be upset. So that would be an example of a one-to-one relationship. One product has one part number, and that part number is what's going to be stored in orders details or order details. So let's talk about that concept that you'll hear about called a parent-child relationship, because this is where I take a little bit of exception to the people that write books versus the people that have to do this for a living. Because the people that write books tend to say that there is a parent table and there's always a child table. And conceptually that's true, but a parent table is not always going to be the same thing. And let me explain that. First of all, let's understand the concept. A parent table typically is the focus of what we're going to be joining this information on. So if I'm coming back and I want to know all the orders from a customer, then my parent table would be my customer table. Okay, I've got a customer and I want to look up all the orders from that customer. That's my parent, the primary table we're dealing with. The child table typically is the lookup table. That's where the data is coming from. So if we go back to this previous example here, this is my customers is my parent to orders. Orders is the parent to order details, and order details is the parent to products in the way that this is laid out. Okay. So again, the parent table is the primary table, the first table. The child table is the lookup table. And you always would then say, an example, grab a parent record and get the child records that match that particular parent record. Now, from the perspective of developing the join, though, both a one-to-one and a one-to-many relationship, again, we have that same design style. So going back to this again, as I said, we've got a parent, we've got a child, we've got a parent, we've got a child, and we've got a parent, and we have a child in here. But there's a problem, and that is that, again, this is where the books, I think, make a big mistake, and that is they tell you to establish what is always going to be your parent table. So, for example, they're going to say that customers will always be a parent of orders, or orders will always be a parent of order details, and so on. But as a person who has to write these select statements, that sometimes is theory, but that's not true. Okay, I would never go back out and say under all situations that customers is going to be a parent over orders. And let me explain why. Okay, here's an example on this slide. What if I want to know all the orders by customer on a particular date? Right? So if that was the case, then all of a sudden I'm changing that whole philosophy behind what I just showed you. All of a sudden I want my orders table to be my parent table, and I want my customers to be my child. Why? Because I want to pull out by date. I want all the dates here. So here's my order date here, and I want to find every product now that this customer ordered on this order date. For that to be the case now, my join is going to change. Again, this will be my parent and this will be my child. Now, later, we will have the opportunity, or our database administrator will have the opportunity to go back in and actually create what we call a foreign key constraint. A foreign key constraint says, let's set this rule up right here as a rule of the entire database. Let's make sure now that and here's why they do that. What if I went back in here and I decided I wanted to delete a customer record out? If I accidentally deleted a customer record out that had orders in it, all of a sudden I'd have what's called orphan records for orders. That means that I'd have a whole bunch. Again, let's talk about Tom Affolter's record. He goes out and he has 50 different orders out there in the orders table. So I have my ID here. If you delete Tom Affolter's customer record out, all of a sudden I've got these orders and order details and products, or actually really only orders and order details out here that are floating that have no customer out there whatsoever. And they would be referred to as orphan records. And orphan records are one way that you can really damage a database, because for the most part they're going to be ignored. If you do a join, orders are going to be ignored, and I will give you some examples of where we can pull those up a little bit later. So let's continue on. I want to make sure that you understand then that parent and child relationships are how you use them at the moment. But going back to what I was going to say a minute ago, putting these rules in and saying these are hard and fast, heavy rules are nice if you always know that you're going to go the same direction. If I know I will always use orders as my child, I'm going to put this foreign key constraint in, because what it will do is it will prevent me from deleting a customer out if there are orders in it. but it will also have a side effect. It will not allow me then to turn around and use orders as a parent over customers. So that's one of the quandaries that we get in a database world, is sometimes you can put too many rules in, and the rules sound really good up front, but you have to make a decision and say, based on how I'm going to use my table, is that in my best interest? Again, we're not going to have to worry about that in this class, but it's something to think about. Let's talk a little bit about what the concept of a foreign key is. A foreign key is the field that you use to look up in a lookup table or in a child table. So if I came back over here and I said to this table, what would my lookup field be to look up records over here? It's going to be my customer ID. Every time I order a product over here, every time I submit an order, I'm going to identify who made that order by putting a customer ID in here. So this guy right here, this field right, let's go back again. This field right here will be the key to get us in to look up the orders over here. No different than this field right here will be the key to come over here and link these fields together to look up the orders in the order details. So we would say then that customer ID is a foreign key. It's a key to this table over here, or that customer ID, order ID here is a key to the order ID here, or again, same thing. Product ID would be a key to look up an item over in the product table. In that case, we would call them a foreign key. A foreign key. And then this rule I was talking about a minute ago, if I write it and I hard code it in the program, it's called a foreign key constraint. And that word constraint means a restriction. And we got to be really careful about those. But it doesn't mean I can't do a join. I don't have to have a foreign key constraint to do a join, and that's the direction I go. I choose not to put my foreign key constraints in, as we're going to talk about later, so that I really have flexibility, but there's also a little bit of risk there. And the risk is that I can delete a parent out and leave these child records sitting alone. Okay, so it's easy to get clouded between a relationship to be joins and key constraints. Again, they're used hand in hand. A key constraint, such as a foreign key constraint, does not physically establish the relationship. Okay, when I do it in a join, if I did it and I hard coded it, which I will demonstrate later, it does. But simply doing a join statement, as we're going to talk about, does not change the structure of your table. It just says, at this moment, here's the data that I want to have returned. So let's talk about, before we go back in and do our first join, let's talk a little bit about when we do a join and we have two tables together and we have a select statement, how do we know what field came from what table? Well, the way that we do it now, in the past we just put the field name in because it knew that we had a from, and it said, well, whatever field that we have in our field list has to be coming from this from table. But now all of a sudden we're going to have two tables that are joined. So the way that we're going to identify which table it comes from is we're going to put the table name in front of the field. So in this case it says the last name in this particular output, if you will, is going to come from the customer table, or the part number field will come from the orders table. So now let's talk about the types of joins that we've got, the physical types of joins. We have what we're going to refer to as an inner join. We're going to take a look at outer joins, and there's what's referred to as a left or a right outer join, and then there's a full join. And we're going to talk exactly which one of those we're going to use. Typically the joins that are going to be the most common joins that we will use as a developer will be the outer join, and most likely the left outer join. Okay, so the inner join and the left outer join would be the most likely ones, but we will see the other ones come up as well. Not as likely the full join, but I will explain what a full join is as well. So an inner join. Now, when we're looking at an inner join, what we're saying is only give me parent records that have children records. So let me give you a couple of for instances of where that might come into play. If we're looking at the baseball data and I want to join baseball with salaries, so I want to know every player and I want to know what salary they earn for any given year, and that's what that join between the two would give me. If I only want players that have ever have a salary record, I'm going to do an inner join. Now, if you go back and you look at our baseball data, you will find that some teams don't have baseball data prior to about 2000, and other teams don't have data prior to about 1985, I believe. So, if I was to do an inner join, I would be telling it, disregard all those people that never had a salary information entered, because it means nothing to me. I only want to know those people that specifically have salaries. Or if I go back to my customer table, I only want customers who have ever ordered a product from me. If a customer has just gone in and registered, but they've never ordered a product, an inner join would never give me that person. It only gives me back parents that have children. So let's go back in, let's take a look at that one. So what I'm going to do is come back in and we're going to do the one that we just talked about. Let's open up baseball here. Okay. And I'm going to show you something here that actually can be a little bit controversial within my own department here at the college. My job is to teach you how to do the best job the quickest possible. My job is not to make you wade chest deep through water when you really only need to be ankle deep. So one of the things that I do is when it comes to building tables, I'm going to have you use a builder. I'm going to want you to understand how it's done by hand, and I'm going to explain that to you. But I'm going to let you use a table builder because that's what the real world is. Now, you might have to build a table by hand later because you're doing it in your code. So I want you to understand the code. Same thing is true with these joins. I'm going to show you how to use a builder to do the join, but we're going to analyze that builder code and understand it in detail because you're later going to write programs that do the joins themselves. Now, let's take a look and see how that's done. So the first thing I want to do is I'm going to do a right click here and I'm going to come down and design a query in the editor. We've already seen this in one previous demonstration, but let's dive into this now. So I'm going to design a query. Now, in this query, the way that you deal with it is you pull out the parent table first. So I want players to be my parent table. So I can either click it and click add or double click it, and it adds. And then I want salaries. Okay, and I'm going to close it out. So now I've got this basic setup together with the players and the salaries. And what I want to do first of all is decide what makes these tables join. Well, what makes these tables join is going to be the player ID. So we have all of the pertinent data about the player, where they were born, where they died, blah, blah, blah. But every time a player plays a given year, they'll add a record to salaries with that player's ID, and then they're going to put the year. Now, to make sure, we didn't want to have to go back in and put all this data in along with this. We want to join it together. That makes it a lot easier. So to join these together, I'm simply going to highlight this player ID column and I'm going to drag across to the player ID over here and let up on it. And you'll notice down below it starts building my join, and by default it's going to default to an inner join, which means by default it's only going to give me players that have salaries. I'll explain in a couple of minutes how to change that. Okay. Now the next thing that I need to do is to select the columns that I want. Okay, so I want to go ahead and in this particular case, maybe I only want to have, let's see here. Let's come back and ask for the player's last name, then their first name. I'd like to know the team that they played on, the year that they played, and the salary that they made during that given year. Now, let's take a look at what it's doing down below here. It's building my join statement for me. And notice what it did is it's given me my column list now. Before, I've only had to put in name last or name first, but now because I've got two different tables here, it's automatically adding in the column name for me when it builds it. Okay. Now, let's analyze what it's saying here. It's saying, give me back from the players table the last name. From the players table, I want the first name. From the salaries table over here, I want the team ID. From the salaries table, I want the league ID. I'm not sure if I want that. I got that backwards. So look at this. I can change this. I want year ID. In fact, let me take all this off. I want year ID, then team ID, then salary. So there we go. I picked the league ID and I wasn't looking for that. So now I've got the year, I've got the team they played on, and I have the salary over here. Okay, then I'm doing the inner join on that. Now look at what happens. I'm grabbing it from players. That's my parent record. So it's still going to have the same from in it. Then I tell it I'm doing an inner join, and I immediately tell it what the table name is. So from the table, inner join the table salaries, and then I have a keyword on, and I need to tell it what are the two fields now that are going to be linked together. What is causing this join to occur? And it's the player's ID PK field in players joining the salaries player ID field directly across. That's what this link is right there. So now I'm going to go ahead and click OK here, and it put it back on the screen for me. Let's increase it a little bit in size. Okay, now let's execute it. And now you'll see what it's given me. It's giving me back the last name, and notice this is all the same player ID record right here. Notice all of this is the same player ID record. But over here is where it changed. Now, David Ardzima, I'm getting his 2004 San Francisco record here and his salary for 2004. And it looks like, it looks like in this particular case, David Ardzima sat out. He sat out 2005 and 2006, and somewhere got traded to the Chicago American League team, and then the following year got traded to Boston, and then got traded to Seattle, and at the very end of his career was at the New York Yankees. And you see for each one of the years, and here's the salary that he made. Pretty simple stuff here, folks. That's what an inner join did. But if you look down the list here, nowhere in here are you going to find anybody who didn't have a salary. Everybody in here included had a salary. So let's continue on and take a look at the next kind of join that we'll be dealing with. Okay, so if we look at this record here, it's saying give me all the parents that have children. So I'm only getting the parents that had children here. This is the parent table, child table. So again, this slide takes a look at that inner join syntax that we just looked at. So remember, we have our standard select statement. We include the column and the table this time. Okay, and now from the table, then we do an inner join on the child table, and we have an on after it, and we just have a field that links the two together. Links the two together. Okay. So in this particular case, this inner join is going to join, we've got orders and we've got suppliers. So what I'd like to know in this one is, it looks to me like I'd like to know on every order who the supplier was. Okay, and I didn't want to have to put in the supplier's company name every time an order, so we put the supplier ID in. So I've got the order number, the total of that sale from that respective order, and then I've got the supplier's company out here. And I'm joining the orders table, okay, which is the parent table here, on a supplier table, which will be my child table, and here are the two fields that link them together, right here. Okay. Now, one other thing I would like to point out is earlier in the quarter, we talked about aliases. We said we can come back in there and we can give any column an alias that we want to. And I also mentioned that we can give a table an alias. And why would we want to give a table an alias? Well, in the early days, it didn't make a lot of sense because we were pulling from one table. But now, here's an example of where we would use a table alias. So what I've got is this top select here, and really this is a very simple example. Where this would be far more pertinent is if we were doing a really large join with a lot of columns in there and maybe even multiple different tables on it. But in this particular case, it will demonstrate the value of it. So what I've got here is I'm joining that orders table that we had previously, and every time I do this, I'll have to type out orders dot. Of course, if I'm using a builder, it will do it for me. But let's talk about doing it by hand, because if you're using a builder, it's not a big deal. But I've got orders dot, supplier dot, the supplier down here. If I went into it, and right here, as you see, I went after orders, which is the table, right here, and I did an as O, and then I went after the supplier table and I did an as S, now I can come back into the rest of my table, and instead of typing out orders, I can do O dot or S dot, and it allows me to do the alias even with the field list. And some developers will think it's a lot easier to look at this bottom one than top one, and I'd agree that it's easier to look at it. The challenge is by looking at O here, I will have to come down and transpose this and figure out O is coming from orders. To me, even though there's more typing up here, this top one is a little bit easier to use, but again, that's technique. You can decide to use it or not use it. So theoretically, we can join 16 different tables together. You saw in a previous slide, theoretically, I had 4 different tables that I would join together. In this class, we're only going to join 2 together as far as any class assignment. But again, I could join 16 tables. That would be a nightmare. I mean, I could not. I think the largest join that I've ever done, and it took me seriously, even with a builder, it took me probably 3 days to get it right, was I think 6 or 7 tables joined together to make it actually work correctly. And I think if I was going to do that, there's better ways to do it. We'll talk later about doing something like that in a stored procedure. But if I was going to join tables, I would probably use a stored procedure, and I wouldn't do a standard join. But nonetheless, this slide right here says once you've got a join, you can put a where clause in there. And on that where clause, as you see here, I have to, in the where clause, tell it right here what column it's coming from and include the table name in front of it. So here I'm pulling out orders, but I only want the total sale that's greater than 3,000 here. So I'm not going to get sales that are 3,000 or less in it. So I can use a where clause the same way. Now, I should also mention that really, if you're going to use the select statement over and over again, this join, you're going to want to make your life a lot easier, and you're going to want to make it into a view. That's what the whole thing's about. Create a view. In fact, you can use the view builder just like we did in the query builder, in order to create a view. But going back again to that last select statement that I had, once I got this guy done, very simply, I can simply come back in here and I've already got this created, but I could come back in and say something like create view, and I always like VW to start with. It's like my Hungarian notation, and again, I'm going to use lowercase VW, and I would give it a name. Usually I like putting in the name of the tables with the parent first, so players, and then this is players salary, and then the keyword as afterwards. I could check it, and I believe I've already got this one created. Let's find out. Let's execute it. I didn't. So now I've got this view, and rather than have to deal with this select statement, all I have to do is, to get the exact same output, just like that, and whether I run that select statement, boom, or I run that view, boom, I'm going to get the same data. And so if it's going to be repeated, if you know you're going to use this join over and over again, make it into a view or a stored procedure, which we'll talk about later. It's not ANSI SQL, but I will demonstrate stored procedures to you later. So again, another great example of where the view comes in handy. So let me get rid of that. In fact, I'll pull all that out. Let's jump back over. I should also mention too, before I go on, that I can put an order by clause down below this and order it. When I do an order by clause, I can order by any column name, because remember now, the select statement will already gather all that data into memory, so the order by clause can actually have a column name in it. So let me come back over here and show you what I'm talking about. Let me Control Z and get back what we had before, right there. Let me get the view pulled out here. So what I could do in here is I could have a where statement, but let's just do an order by. Don't like all this, whoops, don't like all this white space that it throws in here. So I could do an order by last name if I wanted to. And it will let me get away with that. Because why? I can't do it in a where clause, but because a where clause is when the data is being pulled. But right now, with last name, I should be able to run this. Uh-oh. Oh, sorry, name last. There we go. But the where clause, if I do a where clause in here, so let's do something like this just to show you. Let's do something where name last, like, so I want to find everybody who starts with an SM and ends with anything else. Right here. Okay. Oops. So let's go ahead and execute this guy. Oh, it went ahead and worked. I'm surprised it worked. I would have expected that it wanted me to put players back in there in front of it. Well, if it works, it works. In my world, I would have done it this way. I'm surprised it works. I'm not sure if that would work. Oh, try putting that back in again. There we go. Okay. Another thing I want to point out too before I go anywhere else is, let me see. Let me come back in here and edit this out. Let's take this out. Let me see if I can reproduce this again. So I'm going to go back into my builder and edit that query. So it brings it right back. And even if I did one by hand, folks, and I went into the builder, as long as there's not an error in it, I can continue to edit this same way. So let me see. Do I have any fields in here that have the same name in it? No. But what will happen, folks, is occasionally you're going to have two tables that have exactly the same column name in it. And what's going to happen is, because when it's resolved, it's going to throw out the column header. Remember, when I run this thing over here, it just brings back the standard column header. It doesn't add in players in front of name last. If I have a column in the left one and a column in the right, and they have exactly the same column name in it, in fact, I think I do have one I can demonstrate here. Let me pull one up here. Let's go back over to contributions. And I'll show you an issue that comes up here. So I'm in the contributions. I want to do a new query here. I want to design a query in the editor. I want donations to come up, and I want zip codes to come up. Now, what I use this for is, there's two different reasons. Number one, I know my zip codes table has accurate cities and states in it. When I got this table from the federal government, I scraped it. It had cities and states in it, and they were all messed up. So I wanted to validate and make sure the city and state was correct. So first thing I did is I grabbed, I want to grab from here the person's name, the city they're from, the state they're from, and their zip code. Okay. Now, I want to join zip code there to zip code over here. And now what I want to do is I want to bring up, based on the zip code, the actual city and state that it should be. Now, by the way, folks, I've already cleaned this data, so they're going to be exact, but I want to show you what's going to happen here. So now I want to bring up the correct city and the correct state. Now, when I go ahead and click OK, watch what happens. Okay, and let me clean this out a little bit here. Come up with a little bit more territory. Notice that it came back in and automatically gave me a column header that it made up of EXPR1 and EXPR2. Why did it do that? It did it because I already had a city column here, and it couldn't reproduce a city column again, so it says, look, you have to come up with an alias. I can't let you have two columns of the same name. So probably what I'd rather do than have EXPR1 is come back in and call it maybe City1 and State1, so that when I run this, I get back what my table said, what my contributions table said the city and state was, but what my zip code said it should have been. And what I did originally, folks, is I wrote this program just like it was, had the wrong, I had the wrong city and state over here for a lot of them. So once I wrote this statement, I then, which we will cover later, said move from this column here over to this column, the correct city and state, and you'll see that's why they're exact matches. There should be no incorrect cities and states in this table. Okay, so that gives you an example of where that falls in. Let's continue on a little bit more here. So let's talk a little bit about left and right outer joins. The one that we're going to most commonly use is a left outer join. And the only difference between a left outer join and an inner join is a left outer join says, whereas an inner join says, I want parents, only parents that have children. The left outer join says, I want every parent, whether they have children or not, listed. But list the children anyway, but if the parent has no children, just put nulls across where the children information goes. Okay. Now, the right outer join, which is the one that we don't use real commonly, says the exact opposite. It says do the same thing as an inner join, but if you've got child data that exists that doesn't have a parent, list it out anyway. Now, in our case, we better never have child data listed. If there is batting record, it better belong to some person in the players table out there. But that's what we can do with the right outer join, is we can use it to list out in anything from that right outer join that has a that would have a player record that has nulls for the player ID, name, etc. We know that that salary record would be or batting record, if you will, would be an orphan record. So it's used really to look up orphans. Let's come over and take a look at these in actions because they're pretty easy to write. Okay, let's go back to that. We've got this data here, blah, blah, blah. I think, let me see what we got over here. In here, we're joining the salaries table. So remember, when I joined the salaries table with an inner join, I got nobody, I included no players over here that didn't have salaries. But I know that there's a lot of records in my salaries table where players don't have salary records. Because guaranteed prior to the 1980s, any player that played prior to the 1980s had no salary record. They didn't collect it at that point. So let's go ahead and prove that. First thing is I want to show you how to do that type of join here. So I'm going to do a right click. I'm going to go back to my designer here, and it's a simple thing, folks. Watch this. All I do is I go to this join and I do a left click on that join and I tell it include all rows from players. And the moment I click on that, watch what happens. It changed my join to a left outer join right down here. Same thing holds true as we had before. I've still got the same field list in here. I still got the same from. The only difference now is it says left outer join, and I've still got from the table, and I still got the fields from the two tables that join. The only difference between the inner join is right here. That used to say inner join, and now it says left outer join. Now let's take a look and see what that's going to give us when I click OK here. Okay, again, that's all it changed. Let's execute it. And now you're going to see that there are players in here, like Hank Aaron, who played prior to the 1980s. We have no baseball data, no salary data on Hank Aaron over here. Okay, and if you look down the line, there's going to be a lot of different players. So the left outer join said, look, go ahead and give me Hank Aaron, but because he had no salary data or no child record, just put nulls over here. So you can see there's a valid place for that. If I did my orders and I said, give me a list of all my customers, okay, all my customers would list that had orders, but my customers who never placed an order would have nulls where that information would go. Let's go back and take a look at that again. I'm going to highlight this one more time. That's a left outer join. Again, it includes all parents whether they have children or not. Let's redesign that query again. And now let's change it around. Now what I'd like to do is let's get rid of that one and let's change it now to a right join. Now what this is telling me is it says give me children. So I'm going to get all records again. It's still going to give me both joins. But it's also going to give me children that don't have parents, and the opposite of what it did before. Now it's going to give me no records over for players. I shouldn't have any out there. We'll find out here. Let's try it. Okay, click it. Now when I run this thing, I'm still going to get my join, but if I've got nulls over in this area, through any of my records, it tells me that I have orphan salary records. I better not have any orphan salary records. Let's do a where clause just to simplify that, to prove it. So I want those where the players, let's just do where player's last name is null. That would give me the orphan record if it exists, where player ID is null. Okay, and then let's go ahead and run it. Oh, there are orphan records out there. I'll be damned. Okay, so that means I've got some problems out in this table. That means that there are some records, and I'm going to have to go search those records that don't belong to anybody. That's disappointing. I shouldn't have that exist out here. But so again, what it would mean is I have to go back to the record 2014, find out who had this record right here, or at least what the player ID was, because that player ID doesn't exist. It's assigned to a player ID. So how might I find out who that is? Let's go back and modify this join a little bit. So let's design it. Okay, what I'm going to do is put the player ID over here from this right table. So let's add that in. Click OK. Okay, and now let's rerun it. So it tells me that none of these player IDs exist out there in the players table. So bad data. And this data would have been bad because I downloaded this. I've never deleted any records, so this would have come bad from the original data that I pulled. Let's prove that that's the case. Let's copy that piece of data right there. And let's come down here and let's do a select. This is a good learning example. Select star from players where the player ID, PK, is equal to that I've got right here. And let's see if in fact that is the case. Sure enough, that was an orphan record. So that means, and I'm not going to do it now because I think this is a really good example for you to play with. What I would do to correct that is I would go back out there to my salaries table. In fact, and we will cover this later. I would say delete. Oh, let's try that again. Delete from salaries, where player ID, I think that's FK, yep, is equal to Control V. That would clean out that person's record, but I still would have all those other records that I would have to clean out as well. But that shows you how you would wipe out an orphan record that existed. Now, my other choice, if I don't wipe it out this way, is to go back out and find out who this person was and re-add their record again. Figure out why the heck was this person not in that table. That would probably be something that the people that created this table originally would have to do. I think probably when I have time, I might email back the people and tell them that I've got these orphan records out here, rather than me do it on my side. So let's go back again. We've then taken a look at what a left outer join is. It gives me all parents, regardless of whether they have children or not. If they do have children, it will fill it in, but if they don't, it's going to put nulls in. The right outer join is used to come back in and just give me all. It gives me all joins again, like it did before. But if a parent doesn't exist, then it's going to give me nulls for that parent. We just saw that example. Now there's also another thing called a fold join. I don't do a fold join, but a fold join does both sides of it. It gives me everybody's everybody. So let me come back here and show you what a fold join would look like here. Let me take this out. Let me take the where clause out. Let's highlight this guy and let's come back over here and let's redesign the query in the editor. Okay. Now, what I want to do here is a full join basically says I want all rows from players and I want all rows from salaries. And basically that's exactly what it does. It gives me the merged version of a left join and a right join. Okay, it will give me every parent record that exists, and it will give me its children. If a parent has no children, it will put a null there. Then on the other side, it will give me for every child record doesn't have a parent, it will put nulls across. So it's just like merging the two together. Can't think of any time I've ever used it, but it will work. And here is an example. It's called a full outer join here. And if I run it, okay, you'll notice I'll still get the nulls. And then if I go deeper, because we had those other records, somewhere down this list are going to be those records that we saw a minute ago, and I'm going to find nulls over on the left-hand side for those people. wherever that exists. So that's an example of a full join. I don't use that very often. In fact, I can't think of off the top of my head when I've last used it. And then lastly, we'll talk about a self-join. And a self-join is different. It's not the same as the categories of the other. A self-join could be an inner join. A self-join could be, well, most likely it's going to be an inner join. And where a self-join comes into play is when you need to join the table with the same table. Now, what's an example of that? I think I got a pretty good example here. Let's imagine that we've got an employee table, and in that employee table we have every employee that works for the company, including an employee ID. Now, in that same table, though, we might have a supervisor ID. And you're going to put who the supervisor is for that particular employee in that supervisor ID. That supervisor ID is also an employee ID. But we're calling it a supervisor ID because remember, a minute ago we talked about it. We cannot have two employee IDs. Plus, why would I want to call a second one an employee ID when it's the supervisor? But I'm going to put an employer ID in it. So to figure out who that employer is, I'm going to join the same tables together and use that supervisor ID to relate back to the employee ID, and it will tell me who it is. Again, I don't do self-joins real often, but that is a really, really good example of a self-join. So we've covered these joins, folks. We've had some pretty good examples of what those joins look like. I would suggest that if you really want to understand this, you go back and you play with it. Don't just sit here and watch this video. Go back and you do your joins. You've got a whole bunch of different tables in baseball that you can join and play around with a little bit and see what kind of data you can pull up. Now, let's see, there's one other thing that I wanted to cover here with you. Well, I think I pretty much went through the entire gamut of the joins. Again, keep in mind there's a lot more material that I could cover within talking about joins, but this is going to get you by. What you really want to do is you really want to understand that concept of the join syntax. The builder is great, and by the way, that's what I wanted to show you folks, is remember that builder is available here, right down here, but we also, we could add the view as I did before, create view as, blah, blah, blah at the top, but I could also take a little bit more of a shortcut, and if I went down to views right here, I can open up a builder right here, a new view, and the difference between this and the other is this is a full screen builder by default, and when I go ahead and I close it out, it's going to want to save it as a view, but it's the same builder, if you will. I can prove that. If I went back in and said, let's join players with pitching, and let's close it out. Now remember, very few players are pitchers, so this will be a really good learning example here. And the other thing in here too, I believe, well, let's just run this here. Let's play around with it. So I'm going to join player ID to player ID. That's the obvious one. Okay. I want to have, for example, the player's first name, their last name, the year, and I want the team that they played on. Okay. Now, what I might want to do is go back in. I'm going to go ahead and save it. Remember that I could close it like this. I don't have any errors. I know it. I could close it, and if I have no errors, it's going to ask me the name. If I have errors, it will throw me out of the builder, and I will have lost everything. So I'm a big believer that you just come up here, you hit the save button, and now it's going to say what's the name of the view. I'm going to call it VW Pictures. Okay, click OK, and it leaves me in it. Okay, so it's going to give me all the pictures. Now, right now, it's only going to give me players that were pitchers. So it's not going to give me first baseman, second baseman, blah, blah, blah. It's only going to give me pitchers, right? And that's what I would expect out of a join that I call pitchers, right? But if I came over here and I said, give me all, it's going to change it from an inner join to a left outer join. The only data I'm going to get back, pitching data, will be from pitchers, but it's going to include every player ever, and it's going to put null data for everybody that wasn't a pitcher. So that another example of a left outer join or an inner join and where they're pertinent together. And let's go ahead and just for the heck of it, I call it VW Pitchers. Okay, I can close it out now. Okay, now it wants to know at this point. I think it sees that I just made a change, so what I want to do is I want this to be an inner join. So let's make sure that it's an inner join. Okay, so I'm going to go ahead and save it again. Okay, it remembered the previous VW picture, so it didn't ask me again because I'm editing it, and I close it out. I'm good shape. Now I can do select from VW pictures. And did I spell pictures wrong? Let's do my view. Refresh it. P-I-T-C-H-E-R-S. Oh, well, I didn't spell pictures wrong. I spelled from wrong. And there is my pictures view right there. And these are only pictures. I'm not going to have anybody. So every name that I see in here will people that pitched at some point in time. So you see another advantage of it. So hopefully these joins make sense. As I said a minute ago, spend some time, folks. Go back and play around with them. There's a lot of different tables that you can play with. There's a lot of different joins that you can do. You might even want to try to play around a little bit and do 3-level joins just to see what happens. Maybe that team ID, you might find that team ID might relate back to another team franchise table. So you might play around and see if that will work and see what your successes and failures are, because it's how you learn. Thanks a lot, folks.